The universe is vast, but not silent. Across its endless canvas lie the remnants of once burning suns, husks of brilliance that have exhausted their final breath. They linger in darkness like forgotten monuments, a cosmic graveyard scattered through the void. Here, light has faded, yet the weight of existence remains. White dwarfs, crystalline cores, cooling into silence. Neutron stars, collapsed titans, no larger than a city yet heavier than imagination can bear. Black holes, the most enigmatic tombstones of all, swallowing even memory itself. Every star that once blazed with creation eventually meets this fate. Born from swirling nebulae, ignited in nuclear fire, they spend eons illuminating galaxies, only to collapse into stillness. Their fiery birth and their quiet death form a symmetry that shapes everything we know. The iron in blood, the calcium in bone, the gold woven into the fabric of civilizations, all forged in the violent passing of stars. Creation and destruction are not opposites here, but two halves of the same breath. Yet these graves are not only endings, they are mysteries, unfinished chapters in the book of the cosmos. What truly happens to a star when its light goes out? Does a black hole hide information forever, or does the universe find a way to whisper its secrets back into being? Could these stellar corpses, these silent beacons of death, hold the key to the ultimate fate of everything? Galaxies, space-time, even the universe itself. In the stillness of the graveyard of dying stars, a deeper truth waits to be uncovered. For it may not only hold the history of creation's end, but the destiny of everything yet to come. Long before humanity understood the physics of stars, they were regarded as eternal fires, divine lanterns fixed in the firmament, unchanging and everlasting. For millennia, the night sky seemed like a tapestry of permanence. To ancient eyes, the stars never aged, never dimmed, never died. They were the very definition of immortality, in sharp contrast to the fragile and fleeting lives of mortals below. But the telescope, that modest tube of glass and metal, began to unravel this illusion. With Galileo's first lenses in the 17th century, pinpricks of light became worlds with surfaces and moons, vast and imperfect. And yet, it would take centuries before the darker truth revealed itself, that even the stars, those symbols of forever, were mortal. The first hints came in the form of peculiar companions, stars that did not shine as they should. One of the most famous was hidden beside Sirius, the brightest star in the sky. In 1844, Friedrich Bessel noticed that Sirius wobbled as if tugged by an unseen hand. Decades later, Alvin Clark pointed a telescope and saw it a faint star clinging to Sirius like a shadow. This was Sirius B, the first white dwarf ever discovered. Small, dim, and ghostly pale, a corpse of a once radiant sun. It was a revelation that defied intuition. How could such a faint star possess the mass of the sun itself? Spectroscopy, still a young science, offered clues. By spreading starlight into rainbows, astronomers could read the fingerprints of matter. And in Sirius B, they found impossible density, matter so compact that it hinted at laws of nature yet unknown. The conclusion was unsettling. Stars did not burn eternally. They consumed themselves, and when the fuel was gone, they collapsed into strange remnants, haunting the night in silence. From that moment, the narrative of immortality cracked. The heavens were no longer a gallery of eternal fires, but a story of life, birth in clouds of gas, a youth of radiant brilliance, and at last, the quiet descent into death. Humanity had discovered the graveyards scattered among the constellations. The shock was not merely scientific, but philosophical. If the stars could die, then permanence itself was an illusion. The cosmos was not a frozen monument, but a living story of creation and decay. The very forces that shaped galaxies were intertwined with endings, and in those endings, perhaps, lay the seeds of something greater. The realization that stars could die did not arrive in a single moment of clarity, but through a slow and uneasy accumulation of evidence. Astronomers of the 19th century were beginning to peel away the veil of the heavens with instruments more sensitive than anything the world had ever seen. They noticed subtle motions, faint anomalies, peculiar stars that did not fit the expected mold. For centuries, the heavens had been assumed to be flawless and eternal, and yet here were patterns that whispered otherwise. When Friedrich Bessel calculated the unseen companion tugging at Sirius, the brightest star of the night sky, he was met with skepticism. How could such a dazzling beacon harbor a hidden partner so faint as to be nearly invisible? But mathematics does not bend to human belief. The numbers told a story of a massive, unseen object pulling Sirius off its expected path. In 1862, when Alvan Clark's telescope revealed that faint companion with human eyes for the first time, the cosmic illusion shattered. The faint companion, later named Sirius B, looked like little more than a speck beside its brilliant neighbor. But beneath that faintness lay a riddle far deeper than anyone could have imagined. Its spectrum suggested a star of blistering surface temperature, hotter than Sirius itself, yet shining with only a fraction of its light. Its size, when inferred from calculations, seemed impossibly small for its mass. Here was a star as heavy as the sun, crushed into a volume scarcely larger than Earth. Such a concept defied the very physics of the age. No known form of matter could explain how so much weight could be packed into such a small space. The heavens were no longer simple. They were haunted by strange remnants that did not belong to the realm of ordinary stars. As spectroscopy matured, it became a kind of Rosetta Stone for the cosmos. With it, astronomers no longer saw stars as mere points of light, but as chemical furnaces with stories written in their spectra. In the faint rainbow of Sirius B, absorption lines revealed hydrogen gas compressed to extraordinary extremes. The density implied matter behaving in ways that the everyday world had never shown. It was as though the familiar atoms of Earth had been forced into an alien state, one in which their structure was crushed and rearranged by overwhelming gravity. Sirius B was not just a faint star. It was a corpse, a warning of what becomes of even the brightest suns when their fires burn out. Other discoveries soon followed. Astronomers began to catalogue stars that seemed to faint, too dense or too peculiar to fit into the classical picture of eternal, unchanging lights. The concept of stellar evolution slowly took shape, radical in its implication. Stars were not fixed ornaments of the night sky, but living entities with beginnings, middles, and ends. They were born in clouds of dust and gas, ignited by gravity into fiery spheres. They lived out their lives in stable brilliance, radiating energy for billions of years. And then, when their fuel was exhausted, they died. Some collapsed quietly into white dwarfs like Sirius B, their radiance fading into darkness over cosmic timescales. Others ended more violently, detonating in supernovae that scattered the elements of life into space. And for the most massive, the collapse was absolute, producing neutron stars, or even black holes, enigmas that seemed to erase the very fabric of space and time. The cultural and philosophical weight of this revelation cannot be overstated. For thousands of years, humanity looked to the stars as symbols of permanence, as guiding points immune to the fragility of earthly life. To learn that they, too, were subject to mortality was a profound disquiet. If even the stars could die, what hope was there for permanence? And yet, in this unsettling discovery lay something transformative. The death of stars was not meaningless decay. It was a cosmic alchemy. In their collapse, they forged elements heavier than hydrogen and helium, the iron that runs through blood, the oxygen we breathe, the calcium of bone. the gold treasured in human history. Every breath, every heartbeat, every civilization on Earth is built from the ashes of dead stars. The graveyards of the cosmos are not barren wastelands. They are the silent architects of life. By the dawn of the 20th century, the idea of stellar death was no longer fringe speculation but an emerging truth, one that forced science to confront the deep connection between endings and beginnings. The graveyards discovered with the telescope and unveiled with spectroscopy were not just curiosities, they were keystones in the story of the universe. A story where destruction is inseparable from creation, where even the brightest suns must bow to the passage of time, and where the silence of stellar corpses holds the secrets of existence itself. The revelation that stars could die unsettled not only the public imagination, but the scientific mind itself. For centuries, the heavens had been framed as a theater of eternal fire. Stars were thought of as inextinguishable flames, burning endlessly, immune to the slow erosion that haunted earthly life. To suggest otherwise was not only radical, but to many deeply unsettling. The 19th century was an age of industrial confidence, where steam and coal promised endless energy, and yet even the sun, the great engine of life, seemed to stand outside such limitations. How could the great lanterns of the night, so far beyond human scale, be bound by the same finite laws of energy? The growing science of thermodynamics began to cast shadows over this illusion. Calculations revealed that the sun's energy could not be the product of simple burning. If it were made of coal, it would last only a few thousand years. If it burned like earthly fire, it would already be long extinguished. Something deeper had to be at work. The eventual discovery of nuclear fusion provided the answer, showing that stars are engines of unimaginable power, spheres of plasma bound by gravity, converting hydrogen into helium and releasing energy that sustains their brilliance for billions of years. Yet, even nuclear power has a limit. When the fuel is gone, the star cannot continue. Its furnace cools, its structure falters, and collapse begins. What had seemed eternal was now revealed as temporary. Every star was a clock, and every clock must run down. The dawning of this truth inspired both awe and resistance. In the early 20th century, a young Indian physicist named Subramanian Chandrasekhar pushed the implications further than anyone had dared. On a long voyage by sea in 1930, he calculated the fate of white dwarfs. Those dense stellar remnants already hinted at by Sirius B, he found that if a star was more than 1.4 times the mass of the Sun, the quantum pressure holding up a white dwarf would fail. Gravity would crush the star further into states of matter still poorly understood. This limit, now called the Chandrasekhar limit, was not a mathematical curiosity, but a cosmic threshold. Beyond it lay collapse into neutron stars or black holes. Such an idea was almost unthinkable. The great astrophysicist Arthur Eddington, one of the most respected voices of his time, openly ridiculed Chandrasekhar. He dismissed the notion of such collapse as absurd, as though nature itself would somehow prevent it. It was too radical, too disturbing, to be accepted without resistance. In public lectures, Eddington mocked the idea, leaving the young Chandrasekhar humiliated. Yet the mathematics remained unyielding, and in time, observations would prove the young physicist correct. Even Albert Einstein found discomfort in the implications, though his equations of general relativity allowed for the existence of black holes, singularities, where space-time collapses into infinite density. He considered them unphysical, artifacts of mathematics rather than objects that could truly exist. To imagine a place where light itself could not escape, where the fabric of reality folded into oblivion, was too many scientists of the age a step too far. The universe, they believed, must surely have safeguards against such extremes. But the evidence mounted. The strange densities of white dwarfs, the mysterious pulsations of neutron stars, the gravitational grip of unseen masses, all pointed toward a cosmos governed not by eternity, but by cycles of energy, exhaustion, and death. The idea that the universe does not shine forever, that even suns collapse into silence, carried with it a profound cultural shock. Humanity was forced to confront a mortality far larger than its own. The emotional weight of this realization was immense. If the stars could die, then permanence itself was an illusion. The night sky was not a realm of timeless guardians, but of fragile engines burning against time. Astronomy was no longer the study of eternal light, but of fleeting brilliance, of beginnings and endings on scales almost incomprehensible. In acknowledging the mortality of stars, science had taken a step into darker territory, into a universe where death is not an exception, but the rule. Written into the very fabric of existence, the struggle to accept the death of stars was not merely an intellectual battle. It was a confrontation with the deepest instincts of the human mind. Since antiquity, permanence in the heavens had offered comfort against the fragility of earthly life. To look up and see the same stars as one's ancestors was to believe in continuity, in constancy. To suddenly discover that those same stars were transient, that they too carried the seed of their own endings, was to shatter a myth that had persisted for thousands of years. It was not just science that was being rewritten, it was humanity's sense of cosmic belonging. The resistance of Eddington and Einstein was not born of ignorance, but of a natural recoil from the abyss their own equations revealed. The concept of a singularity, a point of infinite density where space-time itself collapses, was more than mathematics. It was an affront to intuition. Nature, they believed, must have boundaries, safety nets that prevented such monstrosities from forming. And yet, the quiet persistence of younger minds like Chandrasekhar showed otherwise. His equations revealed a truth that was difficult to deny. Gravity is relentless. Once the internal fire of a star is extinguished, there is nothing left to hold back its collapse. No law of mercy intervenes. What remains is a husk, or worse, a plunge into forms of matter so alien that even physics trembles at their description. This intellectual conflict mirrored something deeply human, the denial of mortality. Just as cultures construct myths of immortality to soothe the inevitability of death, so too did the scientific community resist the idea that stars, symbols of permanence, must also perish. The pushback against Chandrasekhar was not simply scientific skepticism. It was grief disguised as reason, an unwillingness to let go of the comfort that eternity seemed to promise. The cosmos, once thought infinite in its abundance of light, was being recast as a place governed by limitation and finitude. Gradually, however, the accumulating weight of observation began to shift the tide. The strange properties of Sirius B, the density implied by its spectrum, the mathematical inevitability of Chandrasekhar's limit, these were not anomalies to be brushed aside. They were signals pointing to a universe far stranger than the old picture of eternal fires. As the 20th century unfolded, the boundaries of astrophysics widened. What had once seemed absurd, neutron stars, black holes, the very idea of stellar corpses scattered through galaxies, became the scaffolding of a new cosmic narrative. This shift carried with it a haunting consequence. If stars, with their near-infinite scales of time and energy, could collapse into silence, then nothing in the universe was immune to the law of endings. The cosmos itself could be imagined as finite, destined one day to exhaust its energy, to become a graveyard not just of stars, but of galaxies and time itself. The emotional gravity of this realization cannot be overstated. Science was no longer only charting the mechanics of nature, it was staring into mortality at the grandest possible scale. And yet, within this confrontation with impermanence, a deeper wonder began to take shape. For if stars die, their deaths are not barren. In their collapse, they give rise to the very matter of life. The recognition of stellar mortality did not diminish the cosmos. It revealed the hidden continuity between destruction and creation. The graveyard of stars was not simply a place of endings. It was a cradle, a furnace where the seeds of future worlds were cast into the void. Thus, the first scientific reactions to the death of stars were a mixture of disbelief, resistance, and reluctant acceptance. Out of that struggle emerged a profound new vision of the universe, a vision where death is not a failure, but a necessary chapter in the story of existence. A vision where mortality is not the end of meaning, but the beginning of transformation. The 20th century marked a turning point in humanity's understanding of the heavens. What had once been a loose collection of astronomical curiosities, faint companions like Sirius B, theories of collapse, and mathematical speculation began to take shape as a structured narrative. Stars were no longer regarded as eternal lamps, but as living entities bound to the same laws of physics as everything else. From birth in swirling nebulae to radiant youth, to the quiet inevitability of decline, the science of stellar evolution emerged. It told a story both awe-inspiring and tragic, a story of titanic furnaces burning themselves into exhaustion, of brilliance that was destined to falter, and of deaths that left behind strange, haunting remnants. Yet the universe is not silent in its testimony. It speaks through signals that, if listened to carefully, reveal what hides in the graveyards of stars. In 1967, a young graduate student, Jocelyn Bell Burnell, noticed something unusual while scanning the night sky with a radio telescope. Amid the expected static came a rhythmic pulse, steady, exact, like the ticking of a celestial clock. At first it was suspected to be interference. For a time, the mysterious signal was even jokingly labeled LGM for Little Green Men, so precise and alien was its beat. But the truth was more extraordinary still. The pulsars were the heartbeat of a neutron star, the collapsed core of a once massive star spinning at astonishing speed. These objects, so dense that a teaspoon of their matter would weigh billions of tons, announced themselves not with light, but with radio waves sweeping across the cosmos like cosmic lighthouses. They were named pulsars, and they confirmed that neutron stars were not just theoretical artifacts of mathematics, but real corpses haunting the galaxy. The discovery of pulsars was more than a scientific triumph. It was a revelation of nature's extremes. A star that once burned with nuclear fire now rotated hundreds of times per second, its magnetic field funneling energy into narrow beams that pierced the darkness. It was as if the dead star refused to vanish quietly, instead turning itself into a beacon that announced both its demise and its endurance. Through Jocelyn Bell Burnell's patience and careful eye, humanity had found proof that stellar death did not mean silence. The graveyard of stars was alive with hidden signals, waiting to be heard. Other signs of stellar mortality came from the shattered debris of supernovae. In the expanding filaments of the Crab Nebula, astronomers could trace the remains of a star that had died in a cataclysm witnessed on Earth nearly 1,000 years earlier. Chinese astronomers recorded the event in 1054, describing a guest star that shone so brightly it was visible in daylight for weeks. Now, telescopes revealed its aftermath, glowing tendrils of gas still racing outward at thousands of kilometers per second, carrying with them the heavy elements that would one day form new stars and planets. At its center, nestled like a tombstone, was a pulsar, the collapsed heart of the dead star, still spinning, still sending out its ghostly rhythm across space. The Crab Nebula became one of the most vivid markers of stellar death, a cosmic grave where both destruction and renewal could be witnessed side by side. As astronomy moved into new wavelengths, beyond the visible spectrum, the hidden symmetries of stars grew clearer still. X-ray astronomy, born in the mid-20th century, unveiled a universe far more violent than optical telescopes had ever suggested. Where human eyes saw darkness, X-ray detectors revealed searing points of energy, collapsed stars siphoning gas from companions, neutron stars bursting with sudden flares, and black hole candidates whose gravitational grip accelerated matter to temperatures hotter than the sun's core. What had once been invisible now emerged as blazing signatures of death, scattered across the galaxy. Even the political rivalries of the Cold War inadvertently expanded the search. Satellites launched to detect secret nuclear tests instead recorded bursts of cosmic X-rays, signals that had nothing to do with earthly weapons. These detections revealed Gamma bursts, some originating billions of light-years away, colossal explosions that dwarfed anything imagined before. What began as a tool of human conflict became a window into the cataclysms of the universe, exposing new layers of the cosmic graveyard. Through these early investigations, humanity's understanding deepened. Stellar death was no longer a distant abstraction, but a living reality, recorded in pulses, in glowing nebulae, in invisible rays of energy. Each discovery peeled back another layer of mystery, confirming that the night sky is not a still painting but a restless battlefield of creation and destruction. And with every new observation, the question grew heavier. If the universe is littered with the corpses of suns, then what secrets are buried within them, and what destiny do they hold for everything that still shines? Underneath these unfolding revelations lay an unsettling shift in how humanity saw the cosmos. For centuries, the stars had been regarded as symbols of permanence, eternal points of light, untouched by time. But as evidence accumulated, a different truth emerged, that the universe is not a still canvas, but a living cycle, where even the brightest suns are consumed by their own brilliance. The pulsars, the nebulae, the faint whispers of radiation were not anomalies, but milestones along a universal road of birth, decay, and transformation. What once seemed eternal was now fragile, and the firmament above was no longer a monument to infinity but a reminder of impermanence. This realization carried with it a weight both scientific and philosophical. If stars could die, then the universe itself might one day face the same fate. The investigations of the mid-20th century also transformed astronomy into something more than observation. It became a forensic science, piecing together cosmic crime scenes from the evidence left behind. A pulsar's pulse, measured in fractions of a second, became testimony of a collapse so violent that protons and electrons were crushed into neutrons. A supernova remnant's expanding shell became a record of the exact moment a star had torn itself apart. Even the faint streams of X-rays, captured by orbiting satellites, told of matter spiraling into oblivion, heated to unimaginable temperatures as it crossed the threshold into darkness. Each signal was a clue, each observation a fragment of a story once hidden in silence. The night sky had become a graveyard not only of stars, but of messages waiting to be translated. And yet there was a strange beauty in this new vision of the cosmos. The deaths of stars were not meaningless endings, but engines of creation. From the wreckage of supernovae, new elements were scattered into space: carbon, oxygen, iron, the very ingredients of life. The pulsar's relentless beat became a cosmic metronome, marking time not just for itself, but for the universe it illuminated. Even the X-rays of collapsed stars told of processes that, though violent, stitched together the fabric of galaxies. In the graveyard of dying suns, death and creation were not opposites, but partners, entwined in a cosmic dance older than Earth itself. By the dawn of the space age, the truth was undeniable. The universe was haunted not by silence, but by echoes, by stars that refused to disappear quietly, by remnants that testified to the violence and inevitability of change. Humanity had begun to glimpse the full scale of the stellar graveyard, and with it came a humbling realization. The sun itself, steady and life-giving, would one day join the procession. The investigations of the past were not just about distant stars. They were a mirror held to the future of the solar system, and to the fragile moment humanity occupies within it. The graveyard of dying stars, once suspected through mathematics and inference, gradually revealed itself not only as theory but as image, as signal, as something tangible to human perception. What had been imagined in chalk dust equations on blackboards began to leave imprints in the sky, captured through the instruments of a species determined to pierce the veil of darkness. With each breakthrough, the abstract became real, and the invisible forces that shaped galaxies could finally be traced, if not fully grasped. The first great leap came from light itself, bent, twisted, magnified as it passed near massive objects. Einstein's general theory of relativity had predicted it, but gravitational lensing, once only a bold suggestion, became a new tool to illuminate what was otherwise unseen. A star passing behind another revealed the hidden weight of dark companions. Galaxies distorted into luminous arcs betrayed the presence of invisible masses. Through lensing, astronomers learned that the graveyard of stars extended beyond glowing remnants, reaching into the shadows where collapsed giants lurked unseen. The bending of light became a lantern held up to the darkness, mapping the cemeteries of stars by the ghostly trails they left behind. Yet some discoveries struck with the intimacy of a revelation. In the 1960s and 70s, as X-ray astronomy matured, a particular system came under scrutiny. Cygnus X1, here, orbiting a massive but invisible object, a companion star shed gas that spiraled inward, heated until it blazed with high-energy light. No surface could be found, no signal of matter repelling the fall. Instead, the evidence pointed to a singular conclusion: a black hole, a star's corpse, collapsed beyond any possibility of return. Cygnus X1 became a watershed moment, the first strong candidate for something once dismissed as too monstrous to exist. What had been a mathematical ghost now cast a shadow across the real cosmos. Even Stephen Hawking, who had wagered against its reality, later conceded to the mounting evidence. The idea that stars could die into invisibility, leaving behind only their gravitational grip, was no longer speculation but an observable truth. The instruments of spaceborne astronomy carried this revolution further. The Hubble Space Telescope, launched in 1990, turned its sharp eye not only toward distant galaxies, but also to the remnants of stellar death within our own. It traced the delicate shells of planetary nebulae, the expanding wreckage of supernovae, and the faint embers of white dwarfs cooling into obscurity. Hubble's images revealed the graveyard in color and detail never before imagined. Gases twisted into luminous sculptures, light from dead stars illuminating space like stained glass windows of the cosmos. Through these portraits, death appeared not as silence but as spectacle, a final flourish of beauty written into the night sky. But perhaps the most profound breakthrough came not from light, but from ripples in the very fabric of space-time. In 2015, the Laser Interferometer Gravitational Wave Observatory, LIGO, captured the tremor of two black holes colliding. Their death throes, sending waves across the universe that reached Earth over 1 billion years later. It was as if the cosmos itself had spoken in a new language. vibrations in space-time, confirming what theory had whispered for a century. Soon after, another detection revealed the merger of neutron stars, accompanied by a burst of electromagnetic light. In that instant, the graveyard became a forge, scattering gold, platinum, and heavy elements into space, enriching the galaxy with the seeds of future worlds. The cosmos was no longer only seen or heard, it was felt. And then, in 2019, humanity gazed directly into the abyss. The Event Horizon Telescope, a network of radio telescopes spread across the Earth, captured the shadow of a black hole at the heart of Galaxy M87. The image was a blurred ring of fire, a dark center surrounded by luminous gas swirling at near light speed. For the first time, an idea born in Einstein's equations was painted onto reality. The silhouette of nothingness itself stared back, an emblem of the graveyard that awaits all massive stars. What was once speculation had been transformed into vision, a direct encounter with the most extreme tombstones of the universe. These breakthrough observations marked a turning point. The graves of stars were no longer hidden in the margins of theory or cloaked in invisibility. They had become accessible to human eyes and instruments, confirmed in waves of light, in ripples of space-time, in images that shook the imagination. And yet, as clarity deepened, so too did mystery. For every black hole shadow revealed, questions multiplied. What lies beyond the horizon? Can information survive in the void? And if the universe is filled with such graves, what story are they writing about the fate of everything that shines? The breakthroughs of the late 20th and early 21st centuries did more than validate theories. They shifted the human relationship to the universe itself. Once, the night sky had been a canvas of fixed points, its permanence reassuring, its silence comforting. But each new observation revealed that the heavens were neither silent nor still. They were restless, turbulent, and haunted by invisible giants. Gravitational lensing bent the light of galaxies like glass warped by heat, suggesting that unseen masses, black holes, collapsed stars, and even greater mysteries, such as dark matter, filled the void. What was once a purely theoretical consequence of Einstein's relativity became an everyday tool for cosmic cartography, turning gravity itself into an instrument for finding the unseen. Through lensing, astronomers could trace the outlines of cosmic graveyards, not by their light, but by the shadows they carved into space-time. The discovery of Cygnus X-1 and its successors left an equally profound scar on human thought. Here was proof that the universe harbored objects so extreme that not even light could escape them. The realization was sobering. A star's life, no matter how bright, could end in absolute erasure. But these observations also sparked awe. The X-ray flickers from binary systems were not random chaos, but the final signatures of a process as old as time, gravity consuming matter, space collapsing in on itself, creation transfigured into annihilation. The once abstract black hole was now a presence, detectable and measurable, an unblinking reminder that the universe hides as much as it reveals. Hubble, with its silent orbit above Earth, added to this unfolding narrative, not with equations or signals, but with visions. Its portraits of stellar remnants gave the graveyard of stars a face. Images of planetary nebulae, the delicate shrouds cast off by dying suns, appeared like cosmic flowers blooming in slow motion. Expanding clouds from ancient supernovae shimmered in ghostly hues, vast tombstones that marked explosions seen by ancient civilizations. For the first time, humanity could look upon death in the cosmos, not only with instruments, but with eyes. These images were not just data. They were windows into time, each photograph capturing both the violence of an ending and the beauty of what remained. Yet perhaps the most humbling revelations came with the first detections of gravitational waves. The faint ripple recorded in 2015, less than the width of a proton across kilometers of space, was a vibration from a collision more violent than any ever witnessed before. Two black holes, locked in a spiral of doom, had merged more than 1 billion years ago, and the aftershock of their union had finally brushed against the Earth. It was as if the fabric of reality itself had quivered, carrying a message across the gulf of ages. With that single detection, a new sense opened in science, one not bound to light but to gravity itself. Humanity had learned to feel the universe, and in those ripples lay the proof that stellar death is not quiet but cataclysmic, echoing across space-time long after the stars themselves are gone. The image of the black hole in M87 crowned this age of discovery with something almost mythic. For generations, black holes had been whispered about, denied, debated, then slowly accepted. But to see the dark shadow of its event horizon, encircled by fire, was to confront the unimaginable with one's own eyes. That blurred golden ring became an icon, a human triumph, a cosmic warning, and a reminder that no matter how far science advances, the universe always holds deeper secrets in reserve. The shadow was not just the image of a single black hole. It was a symbol of the graveyard itself, an invitation and a challenge to look deeper into the darkness. With these breakthroughs, the cemetery of stars was no longer hidden. Its tombstones shone in nebular colors. Its whispers resonated in gravitational waves. Its darkest hearts revealed themselves in silhouette. The veil had been lifted, and the graveyard stood before humanity in plain sight. And yet, behind every revelation lingered new enigmas. Why do black holes consume yet preserve information in paradoxical ways? What becomes of matter once it crosses the horizon? Do the ripples of space-time carry clues not only to the past, but to the ultimate fate of the cosmos? With every answer, the mystery deepened, and the graveyard of stars grew not smaller, but infinitely more vast. The deeper humanity ventured into the graveyard of stars, the more it became clear that death in the cosmos is never a simple end. What appeared at first to be silence revealed itself as transformation, a passage from one state of being into another. Stellar remnants, once thought to be the inert husks of extinguished suns, unveiled hidden lives of their own, strange, exotic, and often more extreme than the stars that birthed them. The night sky, dotted with faint white dwarfs, flickering pulsars, and invisible black holes, was not a cemetery of silence, but an orchestra of mysteries, each note pointing to a truth not yet understood. Among the quietest of these corpses are white dwarfs, the dense remnants of stars not massive enough to collapse into neutron stars or black holes. For a long time, they were imagined as fading embers, slowly cooling, radiating their heat into space until they vanished into darkness. But recent observations suggest something more profound. As these remnants age, their matter crystallizes under immense pressure, transforming entire stars into spheres of diamond-like solidity. The galaxy, it seems, is filled with these silent jewels, billions of crystallized white dwarfs, ancient suns frozen into monuments of cosmic time. In their stillness lies a paradox, a kind of permanence that endures long after their fire has gone out. A reminder that even in death, stars can leave behind forms of enduring beauty. Neutron stars, by contrast, reveal death not as silence, but as extremity, composed of matter so compressed that atomic nuclei are crushed into seas of neutrons. They push the limits of physics to breaking point, but even neutrons may not be the final word. Some theories suggest that within their cores, matter dissolves into a soup of quarks, the fundamental particles that compose protons and neutrons themselves. Such quark stars, if they exist, would represent a step deeper into the unknown, a state of matter impossible to replicate on Earth, a glimpse into conditions that existed only in the first moments after the Big Bang. In these remnants, the boundary between life and death blurs into something stranger, stars that collapse not into silence, but into a mirror of the universe's earliest chaos. More unsettling still are black holes, those cosmic abysses that refuse to yield their secrets. Their very existence is paradox, for while they obliterate matter and light, the laws of quantum mechanics insist that information cannot be destroyed. The information paradox remains one of the deepest riddles in physics. If matter falls into a black hole, where does its information go? Does it remain smeared across the event horizon, encoded in ways we cannot yet decode? Does it leak back out through Hawking radiation, slowly unraveling over unimaginable spans of time? Or does it vanish into hidden dimensions, never to be retrieved? In the graveyard of stars, black holes are not merely tombstones, but locked vaults of cosmic memory, and what they hold, or erase, may determine the destiny of the universe itself. Even more haunting are a rare kind of neutron star whose magnetic fields are trillions of times stronger than Earth's. These stellar corpses are capable of tearing atoms apart, twisting space-time with their fury. When they flare, they release more energy in a fraction of a second than the sun emits in 100,000 years. They are stars reborn not as fading remnants, but as violent engines of destruction, as if death itself had been converted into raw power. In the graveyard, magnetars stand as reminders that not all endings are quiet. Some blaze with violence, long after their light should have gone out. Yet, for all their strangeness, the corpses of stars are not sterile remains. They are the seeds of renewal. Supernovae scatter carbon, oxygen, iron, the essential ingredients of planets and of life across the galaxy. Neutron star mergers forge gold and platinum, heavy elements that would never otherwise exist. White dwarfs, as they cool, enrich the interstellar medium with dust that will one day form new suns. Even black holes, by stirring the galaxies around them, regulate the cycles of star formation. The graveyard, it seems, is also a nursery. Death feeds birth, endings make beginnings possible, and the cosmos is renewed through destruction. The deeper the mystery unfolds, the less certain the word death becomes. Do stars truly die, or do they only transform into other forms of being? The crystallized dwarf, the pulsar, the black hole, each is an afterlife, a continuation, a metamorphosis into something that may endure even longer than the star itself. Perhaps, in the end, nothing in the universe ever truly disappears. The graveyard of stars is not an archive of endings, but a library of transformations, each remnant holding within it the possibility of eternity. The mystery of stellar death deepens not only through the forms these remnants take, but also through the timescales on which they unfold. A human life measures time in decades, civilizations in centuries. Yet the afterlives of stars stretch across billions, even trillions of years. A white dwarf that crystallizes into a diamond-like sphere does so over eons so vast that Earth's entire history would be a brief flicker within its cooling. If the universe survives long enough, these objects will fade further still, becoming black dwarfs, invisible, cold relics, no longer radiating even a whisper of heat. No such objects exist yet, for the universe is not old enough to have produced them. They belong to a future so remote it lies beyond imagination, when the Milky Way itself may have dissolved. In this sense, the graveyard is not fixed. It is a slow, evolving landscape where stars continue to change long after their light has gone out. Their silence is not absence, but patience, a testimony to the scale of cosmic time. the interiors of neutron stars speak to a different kind of enigma, the physics of matter itself under pressures so extreme that terrestrial experiments can offer only faint approximations. Inside these remnants, gravity crushes atoms until electrons merge with protons, leaving behind seas of neutrons. Yet what lies deeper within remains a mystery. Some models suggest layers of superfluid neutrons, matter flowing without friction. Others propose a core of quark-gluon plasma, the same primordial substance that filled the universe a fraction of a second after the Big Bang. If so, then neutron stars are not just stellar corpses but fossils of the universe's infancy, holding within them the blueprint of creation itself. Each pulse of a pulsar is therefore more than a metronome of death. It is a reminder that the afterlife of stars may conceal the first language of existence. The paradox of black holes pushes this mystery even further. For decades, Stephen Hawking argued that these objects radiate energy slowly through quantum processes at their horizons, implying they could eventually evaporate. But the fate of the information they swallow remains unresolved. If information is truly lost, the laws of physics as currently known are incomplete. If it is preserved, it must be hidden in ways humanity cannot yet perceive, encoded in the holographic fabric of space-time, or released in faint whispers too subtle for instruments to catch. This tension is more than an academic puzzle. It asks whether the universe itself is logical and complete, or whether there are truths forever sealed beyond its horizon. In the black hole, the graveyard of stars becomes indistinguishable from the graveyard of knowledge. Matters intensify the enigma by blurring the line between death and violence. In December 2004, a magnetar eruption sent a burst of energy so powerful that it briefly altered Earth's ionosphere, despite originating 50,000 light-years away. Such events reveal that even stellar corpses can roar with energy greater than living stars. Their magnetic fields wound so tightly that the very fabric of space trembles. These are reminders that the graveyard is not dormant. It is active, volatile, capable of shaking galaxies with the aftershocks of stellar mortality. To call them remnants is almost misleading. They are engines, still capable of shaping the cosmos around them. And yet, woven into this tapestry of extremes, there is a quiet symmetry. The matter scattered by dying stars is gathered again by gravity, recycled into new generations of suns and planets. The carbon in human bodies was forged in red giants. The iron in blood was born in supernovae. The gold worn as ornaments was created in neutron star collisions. In this sense, stellar death is not the end but the precondition for life. The graveyard of stars is also the cradle of consciousness, the silent guarantor that creation follows destruction in an endless cycle. In contemplating these truths, the question arises, do stars ever truly die, or do they simply trade one form of existence for another, from fire to crystal, from matter to energy, from visibility to shadow? Perhaps what humanity calls death is only transformation on scales too vast to comprehend. A crystallized dwarf may endure longer than galaxies. A black hole may outlast the stars themselves. The elements shed in explosions may carry forward into beings who gaze back at the night sky and wonder. In the graveyard of stars, the boundary between ending and eternity dissolves, leaving behind not silence, but mystery without end, at the extreme edges of science. Where the light of stars dims and the known laws of physics falter, the cosmos reveals its most unsettling questions. Black holes, once thought to be the ultimate tombstones of stellar death, are now seen as both destroyers and archivists. Their singularities, points of infinite density, are places where Einstein's equations collapse into silence, unable to describe the forces at play. Here, Space-time itself is pulled so taut that it unravels, and the distinction between past and future loses meaning. The singularity is not merely a grave, it is a blind spot in the universe's memory, where human understanding fails. Physicists have long sought to pierce this darkness with new frameworks. Quantum gravity, a marriage of quantum mechanics and general relativity, promises to resolve the paradox, though its form remains elusive. Some propose string theory, where particles are not points but vibrating strands, their oscillations giving rise to mass, energy, and even space-time itself. Others pursue loop quantum gravity, envisioning the cosmos as a network of finite loops, preventing true singularities by replacing them with quantum bounces. In such models, the death of a star may not end in oblivion but in transition, a collapse followed by expansion, a star's grave concealing the seeds of a new universe. Hawking radiation adds another layer of mystery. In 1974, Stephen Hawking proposed that black holes are not eternal, but slowly leak energy through quantum effects at their horizons. Over unimaginable timescales, they evaporate, shrinking until nothing remains. Yet this idea leads to the unresolved information paradox. If black holes vanish, what happens to the information about everything they consume? Is it erased forever, violating the principles of physics, or is it encoded on the event horizon like a cosmic hologram? The answers remain hidden, but the question itself redefines what it means for something to exist or to be lost. Some theories suggest that black holes may not evaporate entirely, but leave behind stable remnants, tiny, dense fossils of collapsed stars. These hypothetical relics, smaller than atoms, yet heavier than mountains, could drift unseen through the galaxy. If they exist, they may outlast every star, every planet, every galaxy, silent witnesses to the universe's entire history. In the far future, when even white dwarfs have cooled and galaxies have dispersed, such remnants could be the last structures to endure, a cemetery of indestructible fragments scattered through an infinite night. But the mystery deepens further still. The universe itself seems to be built on invisible scaffolding, a web of dark matter shaping galaxies and clusters. Its true nature remains unknown, but some scientists speculate it may include exotic, stellar corpses, primordial black holes formed in the earliest instance after the Big Bang, or collapsed objects beyond the reach of ordinary detection. If so, then the graveyard of stars may not only fill the universe, but also bind it together, their unseen weight sculpting the architecture of cosmic evolution in this vision. The graveyards of stellar death are not passive remnants, but active architects of the universe's structure. The collapse of stars, the evaporation of horizons, the unseen shadows of dark matter, all may be part of a greater pattern, one where death feeds not only life, but the very form of reality itself. The boundaries between living stars and dead ones, between visible matter and invisible, between being and non-being, blur into a continuum that humanity has only begun to trace. The graveyards are not simply the end of stellar existence. They may be the scaffolds of creation, the invisible handwriting of the cosmos. The extreme edge of science does not offer answers, but rather a mirror reflecting the limits of human thought. In the silence of singularities, in the faint glow of Hawking radiation, in the unseen weight of dark matter, the universe whispers that the story of stellar death is not one of endings, but of deeper mysteries, mysteries that stretch beyond galaxies, beyond time, and perhaps beyond the very laws of physics themselves. Beyond the questions of singularities and evaporating horizons lies an even more haunting landscape, the far future of the universe itself. If Hawking was right, black holes will one day become the last actors upon the cosmic stage. For trillions of years they will dominate the night, feeding on what little matter drifts too close. But they, too, are not eternal. Over time scales so vast that human language barely touches them, they will fade through Hawking radiation, their final flickers illuminating a universe already sunk in silence. The death of black holes marks not just the end of stars, but the unraveling of the cosmos itself. It is here, at this horizon of time, that science confronts its own mortality. In this vision, stellar graveyards stretch forward as well as backward. White dwarfs, cooling endlessly, will become black dwarfs, frozen embers adrift in infinite cold. Theoretical work suggests that some of these corpses may ignite again in cataclysmic black dwarf supernova, detonations delayed by quadrillions of years. Such events would be the last fireworks of the cosmos, the echoes of a creation long extinguished. Neutron stars, too, will slow their spins, their once furious magnetic fields fading into silence. Only the faintest whisper of their gravitational presence will remain. Unseen but not gone, dark energy complicates this picture, pushing galaxies apart at accelerating speed. In this expanding universe, stellar corpses will not drift closer, but instead slip farther into isolation. Galaxies will dissolve into islands, stars into embers, black holes into shadows. What remains will be a cosmos filled, not with light, but with memory. The memory of stars that once burned. The memory of cycles of death and rebirth that sustained creation. The graveyard is not a single place, but a destiny woven into space-time itself. Here lies a paradox that unsettles both physics and philosophy. If every star dies, if every black hole fades, if every structure eventually succumbs to time, what remains? Some physicists turn to quantum mechanics, suggesting that information, the raw code of reality, cannot be destroyed. If true, then perhaps the universe itself is not a graveyard, but a vast archive, a hidden library where every particle, every burst of fusion, every collapse into darkness is preserved in forms humanity has yet to read. Others argue that information may be lost, that the universe is not eternal but eroded, fading into entropy without record. The truth remains unresolved, and within that uncertainty lies both dread and awe. At the extreme edge of science, the story of stellar death transforms into a meditation on existence itself. These corpses, white dwarfs, neutron stars, black holes, are more than ruins. They are boundary stones marking the limits of knowledge. To study them is to look not only into the fate of stars, but into the future of the cosmos, and perhaps into the nature of reality itself. The graveyard of dying stars may not be an ending, but a doorway, leading toward questions no telescope, no equation, and no human mind has yet fully answered in the great cosmic theater. The lives of stars follow a script written not in myth, but in physics. Mainstream astrophysics, built on a century of observation and theory, has traced their fates with remarkable precision. The quiet majority of stars, small, steady, and unassuming, will conclude their existence as white dwarfs. These remnants, dense as no earthly substance, glow faintly with the fading memory of their former brilliance. For billions of years they linger, cooling imperceptibly, until they become cold cinders lost against the backdrop of space. This is the most common ending, a silent destiny written for the countless suns that populate the spiral arms of galaxies, 4 stars of greater mass. The story grows more violent. When the nuclear furnaces within them can no longer resist the relentless pull of gravity, collapse becomes inevitable. The result is a neutron star, an object so compact that a teaspoon of its material outweighs a mountain. These stars do not shine as their ancestors did. Instead, they pulse. Their magnetic fields, channel beams of radiation that sweep across the cosmos with clockwork precision, transforming them into pulsars. To astronomers, these pulses became more than curiosities. They were cosmic lighthouses, marking the presence of stellar corpses across the Milky Way. Stable, enduring, and yet profoundly alien. Neutron stars embody both death and persistence, silent monuments to stellar collapse. But for the most massive suns, the collapse leads to a darker end. In their final moments, they erupt as supernovae, expelling their outer layers in a flash that can outshine entire galaxies. What remains at the core is a black hole, an object predicted by Einstein's equations, but long doubted for its strangeness. Within it, gravity dominates all else, bending space-time into a point from which no light escapes. What once was a star becomes instead a horizon, a boundary beyond which the laws of known physics fall silent. To the mainstream view of astrophysics, black holes are not exotic conjectures, but inevitable consequences, born of mass and collapse. Stitched into the very fabric of relativity, modern stellar evolution models, tested against the populations of stars observed in galaxies near and far, confirm this cycle with remarkable consistency. By mapping the Hertzsprung-Russell diagram, the great chart of stellar temperatures and luminosities, astronomers can trace the life cycles of entire stellar populations. They find evidence of young blue giants destined for violent ends, of aging red giants swollen with dying fuel, and of ancient white dwarfs cooling in the galactic outskirts. Population studies across galaxies reveal that the stellar graveyard is not rare, but universal. Every galaxy, from spirals like the Milky Way to ellipticals, shaped like cosmic fossils, carries within it the record of stars that have lived and died. The process of stellar death is not merely destruction, but renewal. Supernovae, though catastrophic for the star itself, release heavy elements into the cosmos, iron forged in their cores, oxygen and carbon carried on their shock waves. These elements seed interstellar clouds, the nurseries where new stars and planets are born. In this cycle, the graveyard is revealed as fertile ground. Without the ashes of dead stars, there would be no earth, no oceans, no breath in human lungs. What mainstream astrophysics uncovered was not just mortality, but the profound link between death and creation, the endless recycling of cosmic matter that binds every living thing to the fate of ancient suns. At every turn, these conclusions reinforce the great framework of modern physics. General relativity predicts the warping of space-time around collapsed stars, and observations confirm it in the bending of light, the precession of pulsars, and the shadows of black holes. Quantum physics predicts the dense behavior of matter within white dwarfs and neutron stars, and their observed properties match those predictions with extraordinary accuracy. The universe, in this mainstream telling, is not chaos, but order governed by laws so precise that they foretell both the fires of creation and the silence of the grave. Yet, for all the stability of this vision, a whisper of unease lingers. For within these mainstream theories lie hints of mysteries not yet resolved, gaps where equations falter, and where the certainty of physics begins to dissolve into the unknown. Even as science maps the graveyard of stars with greater clarity, the question remains, have we truly reached the end of the story, or is there something more, hidden beyond the horizon of our knowledge? The confidence of mainstream astrophysics did not arise overnight. It was built slowly, piece by piece, as each new observation fell into alignment with theory. White dwarfs, once mysterious anomalies, were explained by the balance of quantum mechanics and gravity. The Pauli exclusion principle, a rule that no two electrons can occupy the same quantum state, became the invisible hand holding these stars up against collapse. Without it, a white dwarf would crumble further, crossing into the domain of neutron stars. In this way, physics transformed what was once a philosophical musing, "Do stars die?" into a precise framework where their fates could be measured, calculated, and predicted with remarkable certainty. Neutron stars themselves confirmed this progression. Their discovery in the 20th century was not just an accident of observation, but a triumph of predictive power. Theoretical work by Bod and Zwicky in the 1930s suggested that such objects must exist, forged in the collapse of massive stars. Decades later, pulsars appeared in the data, their rhythmic signals exactly the kind of phenomenon predicted by theory. Each detection was a resonance between mathematics and reality, affirming that the cosmos behaved as the equations insisted it must. When entire populations of pulsars were mapped, they traced the remnants of supernova explosions across the galaxy, their distribution aligning with stellar nurseries, galactic arms, and the expected geography of star death. Supernova themselves became tools of measurement. The detonation of a white dwarf in a binary system, a type Ia supernova, was shown to always occur at nearly the same critical mass. This consistency allowed astronomers to use them as cosmic standard candles, markers of distance across the expanding universe. From these explosions came one of the most profound discoveries of modern times, that the expansion of the cosmos is accelerating, driven by an unknown force we now call dark energy. Thus, even in death, stars illuminate more than their surroundings. They reveal the nature of the universe itself. The graveyard of stars became a map, not only of endings, but of cosmological truth. Black holes, once regarded with suspicion, gradually emerged as the most convincing evidence of Einstein's general relativity. The discovery of Cygnus X1, a compact object drawing matter from a companion star and radiating X-rays in its death spiral, became a watershed moment. Here was a star that had collapsed past the neutron state into something darker and more final. With time, other black hole candidates followed, their gravitational signatures observed in stellar orbits, their feeding behavior detected in high-energy radiation. The Event Horizon Telescope's image of a black hole's shadow in 2019 marked the culmination of this progression. What had begun as mathematics on Einstein's page became a visible scar in the fabric of the cosmos. Across these discoveries, mainstream theories held firm. They offered a cosmic order that could be relied upon, where each star's fate was written in its mass. Small stars would fade quietly as dwarfs, medium ones as neutron stars, and giants as black holes. The Hertzsprung-Russell diagram became not just a chart, but a story, a sweeping narrative of stellar life and death told in temperatures and luminosities. And when applied to distant galaxies, the same patterns emerged, confirming that the fates of stars were not unique to the Milky Way, but were universal, woven into the fabric of cosmic evolution itself. Still, the more complete the picture grew, the more it hinted at hidden layers. The laws that governed stellar death worked with exquisite accuracy, but they also pointed toward frontiers where known physics began to tremble. What truly happens at the singularity of a black hole? What lies beyond the evaporation of a white dwarf into the cold silence of a black dwarf? Could neutron stars conceal states of matter no laboratory on Earth can create? Even in its triumphs, mainstream astrophysics carried within it seeds of mystery, signs that the story of dying stars, though mapped in outline, was far from finished. In the graveyard of stars, where mainstream science has traced the fates of suns with precision, speculation begins to bloom in the shadows. For every question answered by relativity or nuclear physics, another emerges that pushes against the limits of human imagination. If a black hole is truly a singularity, a point where density becomes infinite, and the known laws of physics collapse, then perhaps it is not an end at all, but a passage. Some theorists suggest that the extreme warping of space-time might create wormholes, tunnels linking distant regions of the cosmos, or even gateways to entirely new universes. In this vision, the corpse of a star does not simply vanish into silence, but becomes a hidden architect, carving new realities from the ashes of collapse. Mathematics allows for such possibilities, even if observation has yet to confirm them, leaving these ideas suspended between science and dream. Others turn their attention to neutron stars, questioning whether their crushing density is the final word. Deep inside their cores, where pressures exceed imagination, ordinary neutrons may break apart, dissolving into a sea of quarks, the fundamental building blocks of matter. If such quark stars exist, they would be stranger than any laboratory on Earth could produce, objects where the very concept of matter is rewritten. Some have proposed that still more exotic states could arise, from hyperons to Bose-Einstein condensates of quarks, each an alien form of existence waiting to be discovered in the darkness. These possibilities suggest that the stellar graveyard is not uniform, but layered, filled with corpses that conceal new and untold chapters of physics. Speculation does not end with matter itself. Some theorists have proposed that black holes might not contain singularities at all, but something entirely different, gravitas, hypothetical objects where the collapse halts at the edge, creating a bubble of exotic energy rather than an infinite point. In this model, the event horizon hides not a mystery, but a kind of cosmic mirage. Though gravastars remain conjectured, they reveal a deeper truth, that humanity may not yet have the conceptual tools to describe what lies at the heart of stellar death. The corpses of stars, in this light, are not merely remnants, they are puzzles, written in the language of a universe still beyond reach. Even more daring ideas imagine stellar deaths as the seeds of creation itself. In some cosmological models, the collapse of a black hole could trigger the birth of a new universe on the other side, hidden from view by the horizon. If true, then every dying star is not an end, but a beginning, each black hole a womb in which entire realities are born. This vision transforms the graveyard into a nursery where endings and beginnings blur into one unbroken cycle. Such speculation cannot yet be tested, but it resonates with a deeper philosophical intuition that death may never be final, but a doorway into transformation from physics. Speculation sometimes leaps into philosophy. The simulation argument, proposed by some thinkers, suggests that all stellar deaths and all cosmic phenomena may be illusions coded into a vast computational framework. In this view, the universe itself is not a physical reality but a program, and the graveyard of stars is simply a design choice, a way for the simulation to generate narrative, drama, and meaning. Whether this idea is profound or absurd remains unresolved, but it reveals the degree to which stellar death presses against the limits of human comprehension. When faced with infinities and paradoxes, the human mind reaches not only for equations, but for metaphors, myths, and digital dreams. And beyond all speculation lies the ultimate fate. Whether through the cold silence of white dwarfs turned into black dwarfs, neutron stars slowing to stillness, or black holes evaporating into faint whispers of radiation, the universe may end as a graveyard spread across infinite darkness, every light extinguished, every structure dissolved, every echo faded, a cosmos of corpses scattered across the void, silent and eternal. Yet even in this bleak vision, there is a strange beauty, for it reminds us that the universe is a story of transformation, not permanence, and that the graveyard of stars is not a place apart, but the very ground upon which reality itself is written. Speculative thought stretches further still, toward the concept of white holes, theoretical opposites of black holes. If a black hole swallows matter and energy beyond retrieval, a white hole is imagined to expel them, forever refusing entry, though no white hole has ever been observed. The mathematics of Einstein's equations allow for their existence as time-reversed singularities. Some have speculated that the Big Bang itself might have been the greatest of all white holes, an eruption of energy and matter from a hidden past. If such objects do exist, then perhaps the corpses of stars are not final resting places, but part of a larger cycle, one where collapse and eruption balance in a cosmic rhythm beyond ordinary perception. The idea is fragile, unconfirmed, yet it lingers a reminder that the graveyard may hold secrets far stranger than the mainstream dares to imagine. Theories of a cyclic universe add another layer to this vision. In these models, cosmic death is never truly final. Instead, the collapse of matter, the exhaustion of stars, and even the evaporation of black holes may lead, eventually, to rebirth. A universe consumed by entropy could, under the right conditions, rebound into a new expansion, igniting stars once more. Some theorists propose that black holes themselves might seed such cycles, serving as bridges between cosmic epochs. If true, then the graveyard of stars is less a cemetery than a turning wheel, grinding down one creation only to scatter the seeds of another. To contemplate this is to imagine eternity not as silence, but as repetition, a rhythm measured not in lifetimes, but in universes. Other speculative frameworks challenge the very nature of the graveyard itself. Could dark matter, the unseen substance that outweighs visible matter by 5-to-1, consist partly of stellar remnants, primordial black holes, formed in the earliest instance after the Big Bang? If so, then the cosmos may already be filled with ancient corpses, silent and invisible, drifting through galaxies and shaping their very structure. This possibility turns every star's death into part of a larger cosmic mystery, the invisible scaffolding upon which galaxies themselves are built. Though evidence remains elusive, the search for primordial black holes continues, for their discovery would link the death of stars to the birth of structure. On the grandest scales, even the concept of information itself has become a field of speculation. Some physicists argue that nothing, not even data, can ever be lost. In this view, the information that describes a star, its atoms, its processes, its light, must somehow survive, even if the star collapses into a black hole. This leads to extraordinary possibilities, that the universe is a vast archive, that stellar deaths are not erasures but encryptions, storing information in ways beyond human comprehension. Others counter that information may indeed be destroyed, that the graveyard is not a library but a void, swallowing the record of existence itself. The debate remains unresolved, suspended between mathematics and metaphysics. Speculation ultimately draws humanity into confrontation with its own imagination. Wormholes, quark stars, graver stars, white holes, simulated realities, none have yet been confirmed, yet each arises from the attempt to follow known laws of physics to their furthest edge. They are not fantasies plucked from nothing, but shadows cast by the equations themselves, glimpses of possibilities at the very boundary between science and dream. And in these shadows lies a lesson as profound as any observation, that the cosmos is larger than comprehension, and that the graveyard of stars is a horizon not only for astronomy, but for thought itself. They stand at the edge of the unknown with tools sharper than any age before. In deserts and mountain tops, in orbit and in frozen Antarctic silence, Humanity has built machines of perception that stretch the senses far beyond their natural reach. The James Webb Space Telescope, now drifting 1,000,000 miles from Earth, is tuned to the faint whispers of infrared light, the cooling glow of stars long extinguished, the embers of galaxies at the edge of time. Its mirrors capture not the blaze of life, but the delicate afterglow of stellar corpses, white dwarfs cooling in silence, neutron stars cloaked in faint halos of matter, black holes feeding in the unseen. Webb does not look for brilliance alone. It listens for the fading voices of stars after death, a record written in wavelengths invisible to the naked eye. On Earth, other instruments rise to match its reach. The extremely large telescope, under construction in the Atacama Desert, will wield a mirror nearly 40 meters across the largest eye ever built to look at the heavens. Its purpose is not simply to admire the beauty of stars, but to count the silent dead. With it, astronomers will map populations of white dwarfs across the Milky Way, tracing the galactic graveyard in unprecedented detail. The faint crystallized remnants of once shining suns will no longer be lost in the background, but revealed as a fossil record of stellar evolution, each white dwarf a time capsule of billions of years. In their distribution lies the story of the galaxy's past, its rhythms of birth and death, and the hidden scaffolding of its future. Yet light alone is no longer the only messenger. A revolution has begun in the language of gravity itself. The detectors of LIGO in the United States, Virgo in Italy, and Kagra in Japan listen to the fabric of space-time as if it were a cosmic drum. When neutron stars spiral together and collide, they send ripples that sweep across the universe, stretching and compressing reality as they pass. These signals carry no image, no photon, but they tell of mass and motion with unmatched clarity. Gravitational wave astronomy has revealed mergers that no telescope could see, collisions of black holes in distant darkness, their death throes shaking the cosmos like distant thunder. Each detection adds another page to the chronicle of the stellar graveyard, confirming that death is not silence but the birth of new signals, new ways of seeing. Alongside these detectors, X-ray observatories in orbit scan the universe for the high-energy scars of collapse. Chandra, XMM Newton, and new SDR reveal the blazing remnants of supernovae, the hot accretion disks feeding black holes, the magnetar flares that momentarily outshine entire galaxies. These signals, invisible to human eyes, sketch the contours of stellar corpses at their most violent. Together with radio telescopes, which trace the whispering beams of pulsars across the void, they build a portrait of the dead not in isolation, but in chorus. Light, gravity, and particles combine into what scientists now call multi-messenger astronomy, a new era where every messenger of the cosmos is invited to speak. To understand the graveyard fully, the universe must also be rebuilt inside machines. Supercomputers simulate the collapse of stars, tracking nuclear reactions, magnetic turbulence, and gravitational implosions that no laboratory could reproduce. Within these simulations, a star lives and dies in the span of hours, its core collapsing, its envelope blasting outward, its remnant stabilizing as a neutron star or caving into a black hole. The calculations are vast, consuming millions of processing hours, yet even the most advanced models remain approximations. Every refinement, the inclusion of neutrinos, the effects of rotation, the chaos of turbulence brings the digital stars closer to reality. These simulations are not merely experiments. They are rehearsals for cosmic truth, projections of what might be happening beyond the veil of distance. International collaboration is the silent engine behind all these efforts. No single nation can map the stellar graveyard alone. The Event Horizon Telescope, which captured the first direct image of a black hole's shadow, was built from a web of radio dishes spanning the globe, synchronized to the precision of atomic clocks. The same spirit binds LIGO to Virgo and Cagra, and Web 2 ground-based observatories. The quest to chart the deaths of stars is a collective endeavor, as vast and interconnected as the cosmos itself. It is not the work of solitary astronomers gazing through a single lens, but of thousands, spread across continents, united by a single pursuit: to learn what becomes of stars after their fire has gone out. As these instruments sharpen and multiply, the graveyard of stars grows less like an abstract theory and more like a landscape coming into focus. White dwarfs crystallizing into galactic diamonds, neutron stars ringing spacetime with their collisions, black holes etching their silhouettes against the light of creation, all are now within reach of direct observation. For the first time in history, the tools exist to follow the story not just in mathematics, but in images, vibrations, and spectral traces. The boundary between speculation and sight is dissolving, and with it the mystery of the graveyard deepens, not in darkness, but in clarity. The frontier of multi-messenger astronomy hints at what lies ahead. Light alone gave humanity its first maps of the heavens, but light is only one voice among many. Now, with gravity, particles, and simulations woven together, the dead stars speak more fully than ever before. They are no longer silent tombstones in a cosmic cemetery. They are active participants in the unfolding symphony of the universe, their deaths resonating through every medium nature allows. And as these signals are captured and decoded, they do more than reveal the fate of suns. They carry with them the possibility of uncovering the fate of the cosmos itself. And yet, even with all this progress, the pursuit of stellar death remains a pursuit of shadows. The James Webb telescope's gaze into the earliest galaxies cannot yet resolve the smallest embers of dying suns. Gravitational wave detectors still strain against the noise of Earth's tremors to capture the faintest ripples from the distant past. Every breakthrough reveals not only answers, but new layers of mystery, reminding humanity that the graveyard of stars is not a single place to be mapped, but an infinite domain scattered across time as much as space. A white dwarf cooling in the nearby Hyades cluster may whisper of a star's end billions of years after its birth, while a black hole merger billions of light years away arrives as a vibration only now reaching Earth, a signal older than human existence itself. To study stellar death is to study time itself unraveling, fragments of cosmic memory arriving out of sequence, stitched together by the patience of human science. Even the most advanced instruments cannot pierce the veil completely. The inner workings of a collapsing star remain beyond direct sight, buried in walls of matter so dense no photon escapes. Gravitational waves, though powerful, give only the broad strokes of mergers, not the intimate detail of how matter is shredded and forged in the furnace of collapse. Neutrino detectors, still in their infancy, glimpse faint particles born from stellar deaths, but their signals are elusive, rare, and hard to decode. The graveyard speaks in many tongues, but none are complete. The full story lies in the synthesis of fragments. Each messenger, whether light, gravity, or particle, is but a shard of the truth, and only when combined do they suggest the outline of the whole. In this interplay of instruments and interpretation lies the fragile beauty of science itself. Human beings, bound to a single world orbiting an ordinary star, dare to reconstruct the deaths of suns across the cosmos with nothing more than faint echoes and subtle shadows. Each new observatory extends the reach a little further, but it is the collective act of weaving the data into meaning that transforms silence into knowledge. In this sense, the graveyard of stars is not only out there, scattered among the galaxies, It is also within the human mind, a landscape charted by persistence, imagination, and the relentless refusal to accept the unknown as unknowable. The path ahead is clear, though shrouded in difficulty. Next-generation instruments like the Einstein telescope and LISA promise to open the low-frequency universe of gravitational waves, capturing signals from the mergers of supermassive black holes that shape entire galaxies. Neutrino observatories buried deep in Antarctic ice and under mountains will refine their ability to catch fleeting cosmic particles, carrying unfiltered stories from collapsing stars. Space-based X-ray and gamma-ray telescopes will hunt the briefest, most violent flares, the signals that announce the birth of magnetars or the shattering deaths of hypernovae. Each will add another layer to the map of the graveyard, transforming it from mystery into a landscape of interconnected processes, where death and creation are inseparably bound. But even as science advances, the reflections it inspires remain as profound as the discoveries themselves. If every star is destined for an end, if even suns must fall into silence or collapse into darkness, then the universe is revealed not as an eternal blaze, but as a place of cycles, endings, and transformations. The graveyard of stars is not a monument to finality, but a record of metamorphosis, of matter and energy reconfigured, recycled, reborn. Humanity's effort to chart it is in truth an effort to understand its own place in that cycle, for the atoms in every human body, forged in ancient supernovae, are themselves relics of stellar death. To study the graveyard is to study ancestry at the deepest scale, a genealogy written in fire and silence. And so the work continues. Webb stares into the abyss of the early universe. ELT prepares to count the frozen remnants, drifting unseen. LIGO and Virgo wait for the tremor of the next great collision. Together they build a bridge, not to banish mystery, but to walk further into it with clarity. The graveyard of stars remains vast, unending, and filled with enigmas yet unsolved. But with each new signal, each faint shimmer captured across the void, the distance between human ignorance and cosmic truth narrows, step by patient step. In this pursuit, the universe itself seems to whisper. The dead are never silent. They speak in echoes, waiting only for ears that can hear. In the vast silence of the universe, the graveyard of dying stars becomes more than an astronomical reality. It becomes a mirror, a haunting reflection of humanity's own passage through existence. Every stellar corpse, a white dwarf cooling in the twilight of eternity, a neutron star spinning out its fading song, a black hole swallowing the last trace of its past, whispers of mortality, of endings that cannot be escaped. And yet, in that silence lies a paradox, both terrifying and beautiful. The death of stars is the reason life exists at all, for when massive suns collapse and explode, they scatter into the cosmos the heavy elements that worlds require. Iron, oxygen, carbon, calcium, the very ingredients of blood and bone, of oceans and mountains, of breath and thought, are all relics of ancient supernovae. Humanity itself is the dust of stellar death, atoms recycled through eons, pieced together into fleeting consciousness. Every heartbeat is a pulse borrowed from a long-extinguished star. Every breath carries whispers of a furnace that no longer burns. To stand beneath the night sky is to stand among ancestors unimaginably old, their lives etched into the particles of the human body. Einstein, who spoke of the curvature of space-time, and Hawking, who wrestled with the paradoxes of black holes, both understood that the cosmos forces humanity to confront infinity. The stars do not only reveal physical truths, they impose philosophical reckonings. They remind us that nothing, not even suns, escapes entropy. But they also reveal that death is not an end in isolation. It is transformation. The collapse of one star may seed the birth of 1,000 others, just as the ending of one life may ripple into countless futures. Infinity is not static, but dynamic, always reshaping itself through endings that are never final in this light. The graveyard is not a place of silence alone, but of resonance, a cosmic cathedral where endings sing of beginnings. To contemplate it is to see the arc of human existence written on a canvas far older and larger than any civilization. Just as the stars once rose, burned, and fell, so too will humanity pass, its creations scattering like dust. And yet, within that recognition lies not despair, but meaning. If the atoms of human bodies come from stars that died long ago, then death itself becomes a kind of continuity, a bridge rather than a wall. Thus, as humanity walks imaginatively through the graveyard of dying stars, it does not only study the fate of suns, it studies itself, its origin, its fragility, and its destiny. For in the diamond cores of crystallized white dwarfs, in the magnetic storms of neutron stars, in the shadows of black holes, lies a universal truth: all things end, and yet nothing is lost. The graveyard is not the silence after the song, it is the echo that lingers, carrying the music forward in ways unseen. And so, the story closes not with an ending, but with a reflection. The stars may die, their light extinguished, their forms collapsed into silence, but their remains build worlds, oceans, forests, and the very beings who look up in wonder. To walk through their graveyard is to glimpse both the beginning and the end, and to realize that they are the same. The cosmos, in all its darkness, tells a singular truth: life is born from death, and death is the seed of life. In the graveyard of dying stars, humanity discovers not only the fate of suns, but the story of its own becoming, and the destiny that still awaits among the stars. The graveyard of dying stars, when seen not merely through the lens of science, but through the gaze of human meaning, becomes something far greater than a map of collapsed suns. It is a meditation on impermanence, a reminder that even the brightest and most powerful beacons in the universe must one day fall silent. And yet, unlike the stillness of a cemetery carved by human hands, this cosmic graveyard is alive with echoes. Each corpse of a star continues to shape the cosmos long after its light has gone out, pulling on the fabric of space-time, scattering the ashes of its elements, influencing galaxies yet unborn. In this way, death is not a void, but a passage, a quiet force shaping futures beyond imagination. This truth resonates deeply within human life. Civilizations rise and collapse, cultures flare like brief supernovae before fading into memory. Individuals live and die with the same inevitability as suns exhausting their fuel. Yet nothing is truly lost. The wisdom of the past seeds the present, just as stellar remnants seed new worlds. A library burned does not erase the ideas that once lived within it. Fragments endure, carried forward in minds and texts, reassembled in new forms. Humanity's story is like the stars, one of cycles and endless rhythm of creation, dissolution, and rebirth. In the graveyard above, people glimpse not only cosmic death, but a reflection of their own fragility and resilience. Einstein once remarked that the most incomprehensible thing about the universe is that it is comprehensible at all, that human minds, themselves temporary configurations of stardust, can peer into the depths of suns and extract meaning is itself a miracle. Hawking, speaking from the prison of his failing body, reminded the world to look up at the stars, not down at your feet, for in the graveyard of stars lies not despair, but wonder, a vision of connection, so vast it defies comprehension. The great physicists and thinkers of history did not approach stellar death as an end to fear, but as a portal through which to glimpse the infinite. Perhaps this is the greatest lesson the graveyard offers, that endings, though painful, are inseparable from beauty. The collapse of a star into a black hole may seem catastrophic, but it is also a doorway into the most mysterious structures of space-time, engines that shape galaxies and sculpt cosmic history. The quiet cooling of a white dwarf may seem like fading embers, yet within those crystalline corpses lies the record of billions of years of light and heat. Even the violent magnetars, tearing reality with their magnetic rage, serve as reminders that death is not silence, but transformation into something unfamiliar. To fear the graveyard is to miss its message. To embrace it is to see that existence itself is a chain of transformations. And in the final reflection, the graveyard of dying stars reminds humanity of both origin and destiny. The elements of life, the architecture of planets, the seeds of future civilizations, all spring from death at cosmic scale. And one day, far in the future, the sun itself will join this cemetery, shedding its outer layers, leaving behind a white dwarf that will cool into darkness. By then, perhaps humanity will have scattered into the stars, carrying its stardust body into new worlds. Or perhaps it will have vanished, another echo in the silence. But the cycle will continue, indifferent and eternal. In this recognition lies a profound peace. To walk among the graves of stars is not to despair, but to understand, to know that humanity is a fleeting expression of an endless process, a brief but luminous flame in a cosmos that thrives on change. The graveyard does not diminish life, it gives it meaning, binding every heartbeat, every breath, to the great unfolding of the universe. And as the final words of reflection rise, one truth remains. The stars die, but through their death, everything lives. The graveyard of dying stars stretches endlessly across the cosmos, a silent cathedral where the choir has long ceased to sing, yet where the vibrations of their hymns still ripple through the fabric of space-time. In these vast cemeteries lie the corpses of suns that once illuminated galaxies, their remains scattered in forms both haunting and magnificent, crystalline white dwarfs cooling into black stones of silence, neutron stars compressed to densities that defy the imagination, and black holes, those invisible tombs whose very presence is known only by the way they bend light, space, and time itself. But to call this place a graveyard is to only half describe it, for in truth, it is also a cradle. Death and birth here are not opposites, but two faces of the same cycle, inseparable and eternal. Every shattered star scatters the seeds of new worlds. Every collapse opens a new chapter in the universe's endless narrative. This paradox lies at the very heart of existence. Humanity, fragile and finite, looks to the stars for meaning, perhaps because, in their stories, it glimpses its own. A life begins in fire, the first breath, like the ignition of hydrogen in a newborn sun. It shines for a time, radiating warmth and motion, building relationships, shaping the space around it. And then, inevitably, it fades. But just as stars leave behind elements that compose planets and people, so too does every human leave traces, ripples of influence that outlast their finite form. The graveyard above becomes a mirror not only of mortality but of legacy. Death does not erase. It transforms, rearranging the building blocks into something new. The science itself confirms this eternal rhythm. Supernovae scatter iron, nickel, and calcium into interstellar space, the very atoms that form human blood and bone. Neutron star collisions forge gold, platinum, and uranium, elements so rare and precious that entire human economies and mythologies have been built upon them. Without death, there would be no life. Without endings, there could be no beginnings. It is in the silence of stellar corpses that galaxies find renewal, for the debris of the dead becomes the raw material of the future. In this truth lies one of the most humbling revelations of astrophysics. The universe thrives on mortality, and yet the graveyard is not only a story of renewal, it is also a reminder of limits. White dwarfs, though long-lived, eventually cool into black dwarfs, cold, lightless cinders, drifting forever. Neutron stars may spin for millions of years, but their pulses weaken, their voices fade. Black holes, seemingly eternal, are thought to evaporate through Hawking radiation, whispering their mass away over inconceivably vast spans of time. If the cosmos itself is subject to entropy, the relentless march of disorder, then perhaps the graveyard is not simply a place of recycling, but the beginning of an end that even the universe cannot escape. Physicists speak of the heat death of the universe, a time when every star has burned out, every black hole has evaporated, and the cosmos stretches into an endless sea of uniform, lifeless energy. In such a future, the graveyard would expand to fill all of existence. Every corner of space would become a tomb, not of silence punctuated by light, but of silence complete, eternal, and unbroken. The story of creation and destruction, so vibrant now, would end in stillness. To contemplate this is to stare into a void more profound than any black hole, a finality beyond finality. And yet, some theorists whisper of alternatives. Perhaps the universe will not fade but collapse, drawn back into a singularity in a great big crunch, seeding another creation, another fire, another cycle of birth and death. Others imagine quantum fluctuations giving rise to new universes, budding off from the remains of the old, like phoenixes rising from cosmic ash. In these visions, the graveyard is not the end, but the womb of infinity, a place where death itself is but a veil drawn across the face of renewal. The truth remains unknown, perhaps unknowable, but in the tension between these possibilities, eternal silence or endless rebirth, lies a mystery that defines the human condition, the yearning to find meaning in impermanence. For what is meaning if not the defiance of oblivion? Humanity writes, builds, sings, and dreams, all in the shadow of mortality. Just as the stars blaze against the night for a brief time, so too does civilization rise and fall in cosmic seconds. The pyramids crumble, the libraries burn, the monuments erode. Yet, in the long arc of history, traces endure. A fragment of music survives in memory. A thought echoes across centuries. A discovery seeds future revolutions. If stars can die and yet give birth to life, then perhaps the essence of meaning is not permanence, but transformation, the way one form gives rise to another. Endlessly, Einstein, who revealed the curvature of space-time, showed that gravity is not a force pulling objects together, but the bending of reality itself. Hawking, who wrestled with black holes, revealed that even the most absolute prisons in the cosmos might leak their secrets, that even horizons are not truly final. Their work stands as a testament to humanity's refusal to surrender before the unknown. To study the graveyard of stars is to confront infinity directly, to ask questions whose answers stretch beyond the limits of human comprehension. And yet, it is precisely in asking that meaning is found. For what defines humanity is not the possession of truth, but the pursuit of it. The graveyard of dying stars, then, becomes a story not only of astrophysics, but of philosophy. It speaks to the essence of being, to the tension between fragility and endurance, between silence and resonance. The stars remind humanity that endings are not failures, but inevitabilities woven into the fabric of existence. To rail against them is futile. To accept them is to find peace. In this way, the graveyard becomes a place of reconciliation, a reminder that impermanence is not an enemy but a teacher. And still, there is the emotional resonance, the profound beauty of knowing that the atoms in every human body have been through this cycle already. Each cell, each breath, is the result of countless stellar deaths. The graveyard is not only out there in the sky, it is within, written in the blood and bones of living beings. To look upward is to look inward, to see the shared ancestry of all things. The cosmos is not separate from life, but inseparable, an endless continuum in which humanity is both participant and witness. As this reflection deepens, one final truth emerges. The graveyard of stars is not an ending to fear, but a story to embrace. For in walking through it, humanity glimpses not only the fate of suns, but its own destiny. The universe is not eternal flame, nor eternal silence, but eternal transformation. The stars die, and yet through their death, galaxies live. Humans die, and yet through their passing, generations rise. The cosmos itself may one day fall silent, and yet, perhaps, through that silence, a new creation may awaken. And so the story closes, not with despair, but with awe. The graveyard of dying stars stretches beyond measure, yet within it lies the secret of existence, that life and death are not enemies, but partners in an infinite dance. To walk through this graveyard is to walk through the story of origins, of destiny, and of meaning itself. The stars may die, their light extinguished, their voices silenced, but their ashes build worlds, their remnants sculpt galaxies, their echoes give rise to life. And in this, the universe whispers its final lesson: nothing is truly lost.